Hi everyone, I hope you're doing well. It's been a really exciting few weeks at Exercism with the launch of Exercism Insiders and then Exercism Premium. We've also had some really great community calls, lots of brainstorming, lots of ideas. We've got lots of improvements to the site deployed and more coming soon. So I feel like there's a lot to be excited about for Exercism at the moment. But nothing is more exciting than month 6 of 12 and 23, which is the summer of S expressions, or more nicely shortened to the summer of Sexps. As normal, I'm joined by the wise sage of programming, Erik. How are you doing, Erik?
Hi, I'm doing well. Another exciting month.
Yeah, it's going to be good. Looking forward to it. So we've got 5 languages this month. We've got Clojure, Common Lisp, Emacs Lisp, Racket, and Scheme. And each of these languages is a dialect of Lisp. And so rather than focusing too heavily on the actual different languages in this video, we're going to be looking a little bit more at Lisp itself, at what makes it unique, its history, how it's evolved, and how it's shaped programming today. And then we will finish by going over the languages in brief and trying to help you decide which one of those languages, or maybe more than one, you're going to explore during the month. So before we get into that, some housekeeping. Firstly, to get the Summer of Sex badge, you need to complete any of the 5 exercises in one of those languages during June. But there's also the year-long 12 and 23 badge, and to get that, you need to solve the 5 featured exercises in one of those languages. And if you're watching this after June, you can do that anytime during the year, so you've not missed out. As many people will never have worked with a Lisp before or tried Lisp before, we've tried to choose relatively simple exercises, but ones that give you a good taste of what the Lisp language looks like and how useful it can be. So the first is Leap, where you get to work with Boolean conditions and truthiness, and maybe optionally as well some lexical scoping. Then we've got Tufa, where you format a string and work with an optional parameter. Difference of squares, where you call user-defined functions and do maths using prefix notation. Robot name, where you work with randomness and atoms and structured data. And then matching brackets, where you use recursion to validate a string. So these exercises and the ones from previous months can all be found on the 12 and 23 page and on the forum. So check that out if you want to work out what you should be doing and dig into all of the different languages we've done this year so far. So Lisp-based languages. I guess we should start with actually understanding a bit more about Lisp. So Erik, can you start by giving us a little introduction into Lisp? What makes it interesting and unique, please?
Absolutely. So the first thing to note is that Lisp is a very old language. As a matter of fact, it's one of the oldest languages there is. And it was created by a programming language, it is. It was created by John McCarthy at MIT in 1958. So that's back when computers were still filling up rooms. And the name stands for Lisp Processing, or Lisp Processor. I find both when doing research. But it showcases the importance of the Lisp data structure to the language. And what that will actually entail, we'll come to later on. But for now, know that Lisp is a list processing language. So lists are core to the language. The language was designed to help with doing AI research, and that has traditionally been a field where Lisps have been used a lot. And what makes Lisp very interesting is that it is actually based on math. So the basics of Lisp are using lambda calculus, which was invented by Alonzo Church. And lambda calculus is a formal system to describe computation in math. So you can describe computation. So I don't know, addition, and you name it, function application in math. So there are rules about that. And these rules are being used to model the syntax and the semantics of Lisp on. So firm mathematical basis, and that has some nice properties, but we'll not go into those yet. It's a highly influential language for various reasons. So as I mentioned before, it's a very old language. It's the second oldest high-level language in use after Fortran. And because it was around when we were starting to program, almost all of the other languages that came after took some inspiration from Lisp. How much inspiration they took it depends. But the language that definitely did do a lot of looking at how Lisp did things were functional languages, because Lisp was the first high-level functional programming language. And many of the features that we now associate with being specific to the functional paradigm, so if you have a functional language, you expect this and you expect that, those were introduced by Lisp. So Lisp is the grandfather of functional programming. What's interesting to note is that Lisp still supported imperative programming, so it's not a purely functional language by any means, but it did introduce many of these functional concepts that we're now used to when doing functional programming. Lisp was also the first language with a garbage collector, so that freed the author from having to do manual memory management, which they found tedious, and they were, well, sort of right, because doing memory management can be very tedious. And Lisp thought, well, let's build a system for that does it for us. And that became the garbage collector. And now a garbage collector is very common. Many languages use it nowadays, albeit in different forms. But Lisp was the one that pioneered it. A fourth reason why Lisp is influential is that it has comparatively little syntax and relatively simple semantics. And these things make it great for education purposes, because you don't have to learn much syntax to be able to understand the language. And the semantics being fairly simple to understand also makes it easier for students to pick up the language, because there are less rules to keep in mind. And for that reason, Lisp, or better said, one of its dialects, is often used to help teach programming in introductory courses. And a final reason that I'd like to mention is that Lisp has spawned and still spawns a great many language dialects, of which we'll discuss 5 today, but there are many more. And in the tree of programming languages, there is a separate branch for Lisp languages, just like there are C languages, and this gives you an indication of how influential Lisp has been.
Nice. Yeah, when I was chatting to Simon Peyton-Jones recently, who one of the creators of Haskell, he was talking about the difference between languages that built around Turing machines and languages that built around lambda calculus. And that was a really interesting. It's really worth checking out that interview. It's on our YouTube channel if you've not watched that already, because it's really interesting to understand, as you say, these two sort of branches of programming languages and how they came out. So you mentioned the syntax of Lisp, which I guess is pretty infamous, specifically the use of brackets, of parentheses. Do you want to tell us a little bit more about that and how that looks?
Yeah, absolutely. There are indeed a lot of parentheses in Lisps, but that's not necessarily a bad thing, for almost the same reason why we don't see curly braces as a necessarily bad thing as C-like languages, although there are people that don't like them. But it's fairly common in C-like language to use curly braces, and not many people actually complain about it. So why do you complain about parentheses in Lisp? I don't actually think it's because of the parentheses, but it's because of the fact that they are used in places where you're maybe not used to using parentheses. So, for example, in function calls. But let's take a little step back and let's discuss a thing that's called S-expressions. So S-expressions, which stand for symbolic expressions, and are often abbreviated as Sexp or Sexp, which is like the summer of Sexp, Sexps. So that's why the name from this month's challenge comes from. And an S-expression is an expression to represent data. So that's fairly vague. But they were invented for and popularized by Lisp, so the original Lisp language. And they can be of two different forms. So either they are an atom, which is like a single X or a single number, and these are the non-nested values. So these are the final form. You don't need to do any additional processing. When you process an atom, that's it. You can think of these as leaves in a tree. But then there are expressions of the form x dot y, which is like the mathematical notation, where x and y are both S expressions. And this is a recursive definition. And it basically means that you can now model trees. So these are the nodes in the tree. So if you want to build a list, you can do x dot and then have y be I don't know, z dot, etc., etc. So you can chain these. And if you chain these, you can get a list. And the list can be used to represent trees. So with S expressions, what Lisp does is it models the code as S expressions. So if you have an integer, that will be an atom. If you have a list, that will be the S expression in the second form. So it's parentheses are used in that second form, so the non-atom form. So if you want to build a list, you use parentheses because a list is an S expression. So you see parentheses being used there. And in a second, I'll discuss why lists are even more core than you might think to Lisps. But the very fact that anything that is not a leaf node is being put in parentheses gives you an indication of how many parentheses there will be.
Yeah, so you mentioned that, Lisp is about dealing with lists. That's what the language is centered around, the clues in the name. So do you want to talk a bit more about this whole list processing part of the language?
Yeah. So a list, yeah, well, it's in the name as you mentioned. So it's list processing. So lists are everywhere. It's the core data structure of Lisp. And in some Lisps, it's even the only data structure. So some have more, but you could have a Lisp with just a list data structure and use it for everything. But to show you how core lists really are, if you want to call a function, you might be used to just having a name and then also some parentheses or maybe no parentheses. But in Lisp, you always have to have parentheses. So a function call is an S expression. But interestingly, if you call a function, the very first element of the list, also known as the head, is the function that is being called. And the other elements, or the tail, so 0 or more, are the arguments to the function call. So what does this look like? So consider adding two numbers. So you might be used to using, 1 plus 2 in the language. So this is called infix notation, where the operator, so the plus, is between the operands. So you have the operand 1, operator plus, and the operand 2. But if you do a Lisp, you use prefix notation. So you would have a list. The first element would be the plus, and then you would have a second element be the 1, and the third element be the 2. So Lisp would interpret the list parenthesis open plus 1, 2, parentheses closed, as the application of the function plus to the arguments 1 and 2. So this is called prefix notation, and it's you don't see many languages using it, and it seems weird at first, but it's actually really, really useful too, because it's makes it really easy to deal with operator precedence. So you might remember from a C that you have the plus has less precedence than a multiplication operator. So multiplication happens before the plus. But in Lisp, you don't have the concept of the precedence because you just use parentheses to have a bit of scoping, basically. So if you do multiplication, you put it into parentheses, and everything within the parentheses is evaluated first. So if you have multiple operators that you want to combine, you will have natural evaluation strategies because they will be in parentheses anyways. So there is no ambiguity. You don't have to learn any operator precedence rules. It's just very easy. And prefix notation, something you have to get used to, but I really, really like it. And a funny thing that this prefix notation also allows for is to have more than two arguments. For example, if you have addition, you could have open parentheses plus 1, 2, 3, 4 closing parentheses. So you could have 4 arguments, and it will work well. So it would do 1 plus 2 plus 3 plus 4. And in a regular language, you would have to repeat the operator, but now you don't, because that's what prefix notation gives you too. So this is all different from what you might know, but there are definite benefits in doing it this way. And interestingly enough, lists are also used to represent source code. I mentioned this a bit before, and we'll go into that a bit more later on. But then you'll see why Lisp is just all about processing lists.
So I think what I find so interesting about Lisp and prefix notation in general is the fact that it does feel so like alien at first when you start using it. But at the same time, there's just such a, as you said, like simplicity to it. And I think that, that idea of everything just being a function with arguments and thinking of things that way and trying to map that into the mental model you already have makes it a lot less complicated to get your head around. I guess there's like that minimal syntax and simple semantics. It makes the language feel in some ways almost a bit like it could be less powerful, but also I guess easy to learn. How is it like different using Lisp in that way, Erik?
It's definitely different. So I used to be sort of afraid of the parentheses, having read what other people had told. But I did end up trying a Lisp, and the syntax is a bit jarring at first because it's so unlike anything you're used to. But because there's so little syntax of it, you quickly get used to it. And once you get used to it, you basically know everything there is about the syntax. And I absolutely adore that fact. So if you start a language, there's also always this hump that you get over where you have to learn all these bits of syntax and what goes where. But in a Lisp, it's all very, very clear. There are just a couple of rules, and almost everything follows from that. And the simple semantics, relatively simple semantics, help with that too. So I found learning a Lisp is both somewhat hard, but also somewhat easy. So if you get over the bit of weirdness in the beginning, because it's unlike what you've seen, the language itself is not that hard to learn because it's really consistent. It's really really minimal. So, but it's still incredibly powerful. I've never felt when doing a Lisp that I was less powerful, and in some ways I'm actually more powerful. But we'll come to that in a sec. But I think Lisp are also what they're often used for is to help when you want to write a compiler or an interpreter. People often start with a Lisp example because Lisp is something that's fairly easy to implement because there's little syntax to parse. The rules are very simple or relatively simple for interpreting. So if you ever want to build your own compiler and / interpreter, Lisp is actually a very good point to start with.
That's cool. Anything else you want to highlight about Lisp before we sort of dig into the individual languages?
Yeah, there's one thing that I must mention. Otherwise, anybody that knows a Lisp would haunt me forever. And that's that Lisp uses the same data type and data structures internally to represent your code. And that sounds quite vague. So let me try and make that a bit more clear. Before I do that, let's make it less clear. So this property is called homoiconicity or being homoiconic. And in other words, if a language is homoiconic, the source code is represented by the same data structures that are being used in the source code. So it's like this, almost this inception-like structure. So I mentioned the lists, but sort and S expressions. But internally, a Lisp compiler will use S expressions to work with the code too. So you are working with lists, but the very same lists, so exact same data structures, are used by the compiler. And you might think, why would I care? But if you pair this with the fact that almost every single Lisp has a macro system where you could get a representation of the code and you could then apply transformations to it, giving you all sorts of very powerful features at your fingertips. The very fact that you can use the same data structure that you're already used to and not have to learn anything new because the compiler is just doing the same things that you are doing. So you can apply all of your knowledge that you already have about, I don't know, iterating over a list or adding things to a list. and apply that to the domain of working with source code. So it's often said that the language treats code as data. So I initially found this very weird, but once you start working with, I didn't really understand it. But if you try to write a bit of macros and then you find that, hey, this is just list processing. So my source code is represented in a way that's it's exactly the same as how you would write it when you would use the data structures that are in the language itself. Then it becomes really, really something clicked for me, and then it becomes really powerful, and you can do tons of great stuff with it. And some languages have use macros to have like a very small core, and they add syntactic sugar via macros. But we'll get to examples later on. But just for now, know that in Lisp, code is treated as data, so you can work with the source code itself as if you were processing regular data that you would define yourself.
And a really nice example of that, if anyone wants to dig into a code base, is the common Lisp representer. I imagine it's probably similar for the other representers in things like Clojure as well. But I remember when I think it was Mark did the common Lisp one, and the elegance of the code and the elegance of the output that he created was just so much simpler than in other language where we're trying to like manipulate the syntax trees and everything else of the generated code that someone writes. Whereas in the common Lisp representer, it was exactly like you're saying. It was just like able to manipulate the code like data. And it made that incredibly elegant. So that's a good, if you want to see Erik's point there in action, the common Lisp representer and probably the common Lisp analyzer data repositories on GitHub are both good ones to look at. So let's dig into the individual languages, Erik. We're going to go by the order in which they were created, which is quite a big range, starting in the 1970s and all the way up to the 2000s. So we'll start with the first one, and the first one that we're going to look at was Scheme.
Okay, Scheme was created in the 1970s by Guy Steele and Gerald Sussman at the MIT AI lab, so artificial intelligence again. It started as an attempt to understand Carl Hewitt's actor model. So you might have heard of the actor model. Carl Hewitt was the one that who came up with it, and they wanted to get a feel for how that would work. And they wrote a tiny Lisp interpreter for that. And then, whilst doing that, they wrote a series of papers, AI memos, and these have been collectively termed the Lambda papers. But you can basically see it as them exploring all different things of the language and slowly building up the language via papers. So interesting start of the language. It's the first Lisp dialect to use lexical scoping, which means that values are only in scope where they're defined. So suppose you have a function and you define a binding, a name with a value, and that value is only available to you within that function. This is just a simplification. But previously there was dynamic scoping, which meant that if you had defined a binding somewhere, you could use it everywhere. But Lisp, the Scheme Lisp dialect was the first that uses lexical scoping, and that's actually now the popular way to do scoping. You ever even, I don't know if any new language uses dynamic scoping, but maybe with some exceptions there might be, but lexical scoping is definitely what most people think of when using scoping. A second thing that they pioneered was first-class continuations, and we won't get into details, but continuations are used in a wide variety of places, for example, with async await in C# and TypeScript, etc. So, and many other places too, but Scheme was one of the first languages to support this. It is an official IEEE standard and also a de facto standard. It's called the Revised Report on the Algorithmic Language Scheme, RNRS. And as it is a standard, there are, of course, many implementations. So you have Shea Scheme, Guile, both of which are supported on Exercism, MIT GNU Scheme, and Racket. And Racket itself is also a language, so we'll come to Racket later. Scheme is a very minimal language with very little syntax, although that was not intentional. So they designed to build a very complex language to do all sorts of complicated stuff, but they ended up building something that was much simpler than they intended. And you so rarely hear that from IT people, that they tried to build something complex, but they built something simple instead. So that was quite funny to me. Scheme has a couple of things going for it. It has proper tail recursion. So in Lisp languages, the idiomatic way to do iteration over a list to go over all the elements is via recursion, and tail recursion is a way to make that be very performance, that you don't get the dreaded stack overflow. You have very powerful numeric data types, including rational and complex numbers. You have delayed evaluation, which is somewhat like promises that you might know from a language like JavaScript. It has a very powerful macro system and something that they call hygienic. I'm not even sure how to pronounce it. Hygienic macros, which reduce the likelihood of unexpected results. But it's sort of a technical detail, but just remember that the macro system is really powerful.
Nice. And then just slightly older than me, we have Common Lisp.
And exactly as old as I am. So Common Lisp was started in 1981. It's an initiative by ARPA manager Bob Engelmore, and he wanted to develop a single community standard Lisp dialect, because at the time there were many different Lisp dialects and they were not source code compatible. So that meant that if some researcher had written code in, I don't know, Lisp dialect A, another researcher couldn't use it in Lisp dialect B. So it was quite a wasteful situation. So they got together and published the first Common Lisp standard in 1984. And they finalized the standard in 1994. So that's the final standard. It's a very stable spec. Mm-hmm. So again, being a standard, there are multiple implementations. So you have Steel Bank Common Lisp, SBCL. This is what we are using by default. You have C Lisp and also commercial implementations like Allegro Common Lisp, LispWorks. There's an embeddable Common Lisp, which you can embed in C programs. And there's ABCL, which runs on the Java virtual machine. So a lot of variety in Common Lisp implementations. So as I mentioned before, the standard is very stable, which means that code written 30 years ago should still run fine today because it's the same standard. And this is an incredible benefit because you don't get upgrade issues where you have to, when you try to update something to the latest version and then it breaks because it doesn't follow the latest standard. But the standard is so fixed that you don't have that issue basically. Furthermore, Common Lisp has a very rich and extensible type system, and it's designed for image and REPL development. And without going into details, it basically gives you very introspective abilities. So the ability to run your code, but then to see what's actually happening to the code, and then to, in many cases, change that on the fly and see how that changes your program.
It's amazing to have a standard that's that stable. Like having talked to some language creators recently, and like looking at, say, the history of C++ and thinking of how that's evolved and changed and is constantly doing that, and how much there is in there, to have something that effectively hasn't changed for 30 years but is still relevant and used today is crazy. So next up we have Emacs Lisp.
Yeah. That was developed a little bit later in 1985, and it was developed for the purpose of having an efficient language to extend a text editor, which was, of course, Emacs. About 80% of Emacs is written in Emacs Lisp, and the other 20% is written in C for performance reasons, but the vast majority of it is Emacs Lisp. It's a bit different from other Lisps. It's not standardized. It's still slowly evolving. I mentioned before that there was automatic tail call recursion, elimination, etc. Emacs Lisp doesn't have that, although they have a workaround, but it's somewhat uncommon for Lisps to not have that. And I mentioned dynamic versus lexical scoping. So Emacs Lisp uses dynamic scoping by default, but they do support lexical scoping, and they recommend it for new code, but the default is still dynamic scoping. So what makes Emacs Lisp interesting is that it has excellent documentation within the editor, of course, because it is so tightly integrated with the IDE. It's of course multi-platform because it runs anywhere where Emacs runs, and that runs in all over the place. You can learn the language by just reading the functionality that you're already using. So if you're using the editor to open a file, you can look at the source code of how does it actually work, and that would give you Emacs source code, Emacs Lisp source code. So you can also learn about the packages that are being used, just read them. And because Emacs Lisp is fairly minimal, they decided they wanted to provide a subset of the common Lisp language, which has a lot of built-in features. It's quite a full-featured Lisp, common Lisp, but you can use a subset of that via the cllib package. So Emacs Lisp has sort of adopted a large part of common Lisp too, if you want to use that.
Nice. It's really interesting. I always thought like Emacs Lisp was just like a bit like Vim script, where it was like a load of stuff that was built on top of the editor. I didn't realize that actually Emacs was written in Emacs Lisp. That's I like that. That's cool. So moving forward a decade, we move to Racket.
Yeah, Racket was developed by Matthias Felleisen, who founded PLT Inc. in 1995. For the purpose of developing a pedagogic programming environment based on Scheme. So with the goal of teaching. It was originally named PLT Scheme and later renamed to Racket. And it was designed to help teach programming to new students. And Scheme was great for that because it was such a minimal language. So the aforementioned reasons why Lisp are great for learning definitely apply to Scheme. But Racket was also designed as a platform for programming language design and implementation. And we'll come to what that means later on, but it's a very interesting aspect of Racket. It's a descendant of Scheme, but it's more modern, as it is evolving more than Scheme is. And of course, it supports functional programming, etc. But what I found really interesting is that and this harkens back to previous months, that it supports logic programming. So there is a Prolog-like language that you can use within Racket. And I was quite amazed to see that, how that would work even. And they made it work, so that was quite a feat. So Racket has simple, expressive syntax. It's ideal for beginners, but still powerful for experts. It's like a sales talk almost, but it is true. And Racket supports many different programming paradigms. So I mentioned logic programming. Of course, you can do functional programming, but you can also do object-oriented programming, design by contract, meta programming. So Racket is a true multi-paradigm language. But basically, all of the languages that we're discussing here are multi-paradigm because you can do functional and imperative in all of them. And some of them also support object-oriented programming, like Racket. It's quite like Common Lisp, quite a full-featured Lisp in that it has a very comprehensive standard library. So a lot of stuff already built into the base library, and it comes with a quite a unique feature in that it has its own IDE, Dr. Racket, and it's designed for learning and exploration with a minimum of hassle. So it has a dedicated IDE, and Racket has lots of documentation and a lot of background information because it was designed to help teach to students. So you have to have documentation to do that.
Clojure is the final one we get.
Yeah. So Clojure was developed by Rich Hickey in the 2000s, near the end, and it was with the goal of having a modern Lisp that runs on the Java Virtual Machine, the JVM, and one that has great concurrency features. So, like the other languages, it's a dialect of Lisp, but it's also somewhat different from other Lisps. in that it also doesn't support implicit tail recursion. Don't worry, but you can work around that. But what really is different from the other languages is that it has many more data structures than just lists. It also has maps, sets, vectors, and these all have their own literal syntax. So it's not uncommon for another Lisp to also have another data structure, but usually they don't get their own literal syntax. So usually it's like you would have a function where the function is a vector, and then you would pass in its arguments, and you get a thing back that is a vector. But Clojure went a bit further than that, and they introduced syntax that is specific to maps, sets, and vectors. All of these data structures are also immutable, so you can't change them. But due to some very clever algorithmic design, they still have great performance. If you're interested, it's O-log32n, which is effectively constant time, but just remember, it's fast. Even though they are immutable, they're fast. Clojure supports runtime polymorphism, which is not something that many Lisps do, via multi-methods and protocols, without going into detail to that. But it's like multiple dispatch, but very, very powerful, and you can dispatch on different things. Really, really cool feature. Of course, running on a JVM, JVM interop has to be good, and it is. So you can interop with everything that's already out there and that's running on the JVM. And there's a really fun Clojure spec data specification system, which is like a runtime specification verification library where you can generate data, you can do property-based testing, define the structure of data, and have validation. So very, very powerful stuff.
Nice. Super comprehensive. Thank you, Erik. So in terms of where these different languages are used, where do you see them used? Where would people choose to use one of these over the others today? Starting with Scheme.
Oh, sorry. Yeah, Scheme. I was so anxious to begin. Scheme is used in education to help teach computer science. It's used in AI, so that's a common field where Scheme is being used. You can use it as a scripting language. It has been used in GIMP, the graphics editor, and CAD tools, and even for I had a mention of the movie Final Fantasy: Spirit Within to script the rendering engine. So those cool. Use cases would apply to Scheme.
Nice. Common Lisp?
Yeah, Common Lisp is used in many places. And for example, artificial intelligence again, but also research. But Common Lisp is quite is being used in the commercial domain too. So NASA wrote autopiloting software of the Deep Space One spaceship. There was a product called ViaWeb that was written in Common Lisp, and that was later acquired by Yahoo and rebranded as Yahoo Store. And there's an interesting article somewhere where they mentioned that Common Lisp was their secret sauce, and that made it why they could compete with others and they could outcompete them. So look for ViaWeb Common Lisp and you'll find a very interesting article. And the first version of Reddit was written in Common Lisp, or at least parts of it.
Fascinating. I like the idea of building autopiloting software in it. That's cool. Emacs Lisp. I mean, I guess this is used in Emacs.
You guess right.
Anything else?
Now, basically, it's used in Emacs, and you could use it as a scripting tool too, because Emacs is basically an interpreter for Emacs Lisp. So you could see it just as a dialect of the Lisp programming language, but with extensions to support text editing. So Emacs Lisp is used in Emacs. It makes sense, I think.
Nice. Yeah. Racket?
Racket is used in education, which is what it was designed to do, but also on in places where you want to build new languages or just try out new languages. Is used in research. It's also used in games. John Carmack, which you might know of being the author of Doom and other famous games, he used it in this interactive scripting environment for the VR headset where it was working on. And if you're into games, you might know Naughty Dog, which are well known for the Uncharted series. Great game. And they wrote all of their scripting in Racket. Mm-hmm. And Hacker News is written in Arc, which is a Lisp that was itself written in Racket. So it's a bit indirect, but Arc was written in Racket, and it is a Lisp. And that is being used on Hacker News.
Both Hacker News and Reddit originally starting out as Lisps.
Yeah.
I did not know
all the cool kids.
Yeah, all the cool kids. And then finally, Clojure, the most modern one, I guess.
Yeah. So Clojure is used also for many different things. It's a very general purpose language. For example, there was a company called Atomist, which was acquired by Docker in 2022. And that's a container security and automation platform. And this shows that Clojure was designed for having good concurrency. So anything that has to do with on the web and being concurrent and scalable, Clojure is great for that. And the biggest user of Clojure is Nubank, which is a very new bank that so it's, I don't know, maybe 10 years old or something like that. And they are using Clojure for their banking systems. And they've actually hired the core Clojure team to work within their company. So the core Clojure team is employed by Nubank. And Clojure is also used for rapid prototyping because it's very dynamic and highly interactive with its REPL.
Nice. And then we normally spend a bit of time in these videos looking at how sort of the languages differ from a programming perspective. I guess they're all quite similar, but are there any fundamental differences other than the things you've already mentioned?
Well, they are indeed quite similar. They all support functional programming, imperative programming, and what's called symbolic programming. And symbolic programming is the it's like the meta programming stuff where you have the source code that's being represented as symbolic expressions, so S expressions. So you can work with that. But some of them also support object-oriented programming, and Common Lisp is probably most well known for this in that they have very specific object-oriented support, which other Lisps usually don't have. They're all mostly dynamic languages, although the Racket language supports a dialect that allows for static typing to be added, but in general, they're all very dynamic. But that does not mean that they're all interpreted. They're basically being used in any way you can think of. So they are interpreted without a compilation step, but they're also interpreted with the compilation step. They are compiled to bytecode, then interpreted, or directly compiled to machine code. And which language supports what differs based on the implementation. So some Common Lisp implementations support compiling to machine code, others are interpreted, and the same goes for other languages. And just yesterday, I saw an article of Scheme actually being developed, was developing WebAssembly support, so running Scheme directly in WebAssembly. So there's a lot of different ways, but they're mostly functional imperative languages that are dynamic.
Okay. And then continuing to look at this from a programming perspective, do any of them have any particular sort of standout features that are interesting with your programming geek hat on?
So Scheme is, I would say, its standout feature is it's minimalism. So there's just a very, very small core. And with that core, you can still be very expressive, and it is still very powerful. And you just have to learn very little syntax and semantics. So easy to learn, and for that reason, used in introductory computer science courses a lot. And the second standard feature is its first-class support for continuations. And you can think of a continuation as almost like a save point. So a representation of a specific state of a program, and that can be halted and then later on continued. hence continuations. And you can use this to model control flow, for example, a return construct that you might be familiar with from more imperative languages, but also coroutines, which allows for things to work in parallel. In general, Scheme just has great support for that built into the language.
Nice. Common Lisp?
So just mention it that Common Lisp has great object-oriented programming. It's called the Extensible Object-Oriented System. So there's I won't go into detail, but it's very, very flexible, and it allows you to show how super or subclass methods are combined, and you can sort of inject code to make things work differently than what it does by default without modifying the source code. So it's really powerful, and if you're interested in doing OOP in a Lisp language, Common Lisp is great for that. It also has a programmable condition system. So you're probably familiar with exceptions, and exceptions are usually having two parts. One part that signals the error, so throwing the error, and one part that handles it, so the catching. But in Common Lisp, there are actually three phases. There's a third one, and that's the restarting. So you can have code that signals an error condition. You have code that handles it, and then you have code that can decide, how should I deal with it? Should I restart the program? Should I maybe reset it to some state? And Lisp allows you to do that in three distinct phases, and it's very powerful and incredibly flexible. And if you have used exception-based languages, this is definitely something that you need to look at, because it's really, really cool. And then the final standout feature is Common Lisp macros. So they can be used for extending the syntax of the languages. So you don't have to generate boilerplate code, but you can also add new syntax. And you can use this to effectively build DSL, so domain-specific languages, with relative ease. And it's a very powerful system.
Nice. You mentioned Emacs Lisp was a little different, and also that fundamentally it's just living in the editor, allowing you to do stuff. Is there anything that jumps out about Emacs Lisp for you?
Well, of course, it has great editor support and integration, so that's a given. You can work with Emacs Lisp to customize Emacs while it's running. So somebody mentioned this is like doing brain surgery on yourself, which I don't recommend you doing. But if you are working on Emacs, you can tweak things on the fly and see it be applied immediately. Now that's without doing any, compilation or whatever. And you can also use Emacs Lisp in batch mode. So you can run it as a script, but you can then use all of the editor's capabilities. So reading files and applying transformations. You can even work with cursors and move to the beginning of the line, end of the line, etc. So it's like having a headless editor almost. So that's quite powerful. It's a very different way of working with data if you are working it from the viewpoint of an editor.
Fascinating. Racket?
Yeah, Racket has also a very powerful macro system. It's a theme. So a lot of things are implemented as syntactic sugar via macros, and they are hygienic. I don't know the word. So it's basically macros are less likely to have unintended side effects, and they're incredibly powerful, and they are used all over the place in Racket, and in fact in most Lisp, but the one in Racket is really, really powerful. Nice. It's also a language-oriented language, so that sounds a bit weird, but Racket comes with all the tools to help you write your own programming language or DSL, all built on Racket's macros. And that's also why, for example, Racket has built-in languages that are different from the Racket language. So you have typed Racket, where you can add static typing to your code. You have the data log dialects built into. This is the Prolog-like language, so the logic-based one. And all these languages have Dr. Racket IDE support. Oh yeah, there's another one that's called Scribble, which is a dialect to create prose documents in HTML or PDF form. So you could use this for, I don't know, writing a book or whatever. But in general, Racket is really, really powerful if you want to write a new language or a little DSL, or maybe a big DSL. And then finally, in Racket, the REPL, so the read eval print loop, which is like a little console application where you can enter stuff and it will immediately be evaluated, is actually a core part of the development workflow. So not just for trying out things, but also to look up documentation, etc. And continuing with Clojure, this has the exact same standout feature. So the REPL is also great in Clojure. So a lot of when you're doing, I don't know, C or C#, you're used to writing code, compiling, running. But a REPL based process is much different because it's very interactive. You get immediate feedback. So the loop that you're going through constantly isn't being bogged down by compilation times or whatever. You're just constantly trying to explore things, and Clojure is great at that. And Clojure also has an incredibly powerful macro system. So a downside of these languages being very similar is that I keep on repeating myself. But it has great support for macros, and a lot of syntactic sugar is being built into the language via macros. So and this might seem like insignificant to the user, but the very fact that the macros allow language features to be added via macros means that the core of the language can remain very small, so you can understand the core easily, and it's also less likely to have bugs, for example, because less code that being written, less likely you have bugs.
Nice. Okay, so finally, then, if someone's looking to try one of these languages out in June, which would you recommend they would try?
Yeah, I expected this question. Well, if you're interested in Lisp in general, I would say they're all good options. But that said, I do have some recommendations or suggestions. For example, if you've never tried the Lisp before, I think Scheme and Racket are great options to begin with, for the fact that they have relatively minimal syntax, and that makes it easier to get started with. But that said, Common Lisp and Clojure both have learning mode on Exercism. And that is absolutely a great way to start learning the language. So I would say those 4 languages are great to start with if you are new to Lisp. And if you're already using Emacs, then you might want to try Emacs Lisp. It's a more natural choice to you, I think, because then you can experiment with your Lisp code directly from your editor. And if you're used to working with JVM languages like Java or Kotlin, maybe Clojure makes sense because you would already be in an ecosystem that's familiar to you. Emacs Lisp via Emacs, Clojure via, for example, IntelliJ, and Racket via Dr. Racket all have excellent IDE support. And that's not to say that Common Lisp or Scheme don't have good IDE support. But I found the Emacs, Lisp, Clojure, and Racket editor support to be incredibly useful, especially when you start out with a language. You could use any little help you can get, and a good IDE can definitely give you that. Another suggestion is that if you want a really full-featured Lisp, so a Lisp that has a lot of stuff built into the language, I would recommend either Common Lisp, Clojure, or Racket, as they all are very extensive. So you get a lot of stuff already built into, whereas Scheme and Emacs Lisp are by definition more minimal, although you can have the subset of Common Lisp being used in Emacs Lisp. But yeah, so it depends a bit if you want to, I don't know, build a networking server or something like that, it's far more likely that you get something already there for you in those languages.
Mm-hmm.
If you want to try a somewhat different Lisp from the others, I think Clojure is probably the most logical choice because it has some fairly unique syntax for Lisp. It's also the most modern Lisp. So there are things that have been that they learned that might be useful. For example, the whole concurrency thing is actually a core part of Clojure, where it's less of a thing in the other languages. So I think Clojure is probably the most different Lisp out there. So if you fancy, or maybe you've done a Lisp before, if you haven't done Clojure, maybe try out Clojure and see if you like the ways in which it is different from a common, I would say a common Lisp, but that's quite a bad way of putting it, like another Lisp. And then finally, if you're interested in symbolic programming, macros, meta programming, so using code to work with code, to either, I don't know, generate code or transform code, I would say they're all good options. But if you are particularly interested in building a new language in a Lisp, I would highly recommend Racket because it was designed to be great for that. And
Mm-hmm.
there are lots of examples of people using Racket to build a new language. And like every month, if you have some time, I would recommend you trying out a couple. Of the 5 exercises we are featuring this month, maybe try out them in a couple of languages and see what you like about them and what you don't. We're always very interested in hearing about what people like about languages. But in general, they're all very fun languages, and don't think that the parentheses will be in any way a big barrier to you learning the language. It's a little barrier, but you'll get over it soon, and maybe you even come to love the parentheses like I did.
Awesome. Thank you, Erik. That was brilliant. I would say that I know a huge amount of love and hard work has gone into the Common Lisp and the Clojure tracks on Exercism in particular. So both of those have got really outstanding learning modes. So yeah, definitely worth giving one or both of those a shot as well if you want to just learn Lisp for the first time. That was amazing. As always, thank you, Erik, for being so wise and so much preparation, energy into all this as well. I hope everyone has a really fun month. There's lots of Lisp enthusiasts around, so do come and chat on our Discord or on our forums, and I'm sure there's going to be lots of people who are up for getting geeky about Lisp or helping you get unstuck. But yeah, have a great month. Thank you for watching this. If you made it all the way to the end, especially, and look forward to seeing you next month for July. Thanks.